All right, let's get a full screen up here. Yeah, I woke up this morning and I'm feeling a little differently about log base 2 of 3, that calculation. So I'd like to share some of the things I was thinking about. I always give consideration to where a class is at and where it needs to go and what needs to be said. And so I start mulling around a few things in the old noggin, and I'd like to share what I was thinking about this morning with you. So exponential functions, still trying to get students to be able to graph them and understand them on a real basic level. So just starting with 4 dots, and I decided to double them every year. A magical moment here. Yeah, so time is happening very quickly as we're speaking. And we can see that after, this is kind of an initial amount, time 0. I mean, I could have made that the year 2025, and I might a little later on. But right now, let's just think it's an initial amount of 4 dots. A year later, those 4 dots double and are 8. And I got tired of drawing dots, so I used a bar to represent those 8 units here, and I doubled them. So now they're 16. And then I quadrupled them because I'm doubling every year. So every 2 years, I quadruple. And I can't draw anymore because those differentials are outside my range. Can't reach any higher. But I can definitely start to see trajectory, the exponential growth trajectory. But unbeknownst to you, I've been doing this forever, even before the Big Bang. And not only can I see growth in this direction, but I can kind of get a feeling for decay in the past. So 4 dots used to be 2. And those 2 used to be 1. And that 1 dot was actually cut in half, and I don't even know how to show that dot. And that's cut in half again, a 4th. And I can get to see the kind of exponential decay as I think about this in the past. All right. Well, it'd be nice if I could write this as a symbolic expression, because it takes time to express it to you this way. And I think what we need is Rene Descartes to help me out here, but I'll move towards Rene slowly. So let's collect some data and put it in functional notation. I think initially, time 0, I had 4 dots. That's my amount at that time, 4. 1 year later, I had 8. 2 years, 16, so on and so forth. But I could have also gone a year in the past, and that would have been 2. And 2 years in the past, that would have been 1. And I'm getting outside my range. 3 years in the past. Oh, 1/2. That's as far as I'm going to go. Okay, I think we're building a model, A, B, D, X plus C. That's the exponential model. And C in this case, I could change it. I could say, hey, I'm measuring from a height of 50 inches. Then that would be 54 inches and 58. But let's keep it simple. Let's just consider C to be 0. So I have a model that's fitting the A, B to the X format. All right. So still thinking about log base 2 of 3. Well, what if I was doing it every 10 years? Let's say that instead of every year, I was doing it every 10 years. Well, that's been a test question, right? Start with an initial amount of 4. Always been 4 sheep and gill. Let's double the population every 10 years. Well, now A of 0 is still 4. It's what I started with, but now A of 10 is equal to 8. And A of 20. 20 years from now, I get 16, so on and so forth. And A of minus 10 gets us 4. And if I wanted to shift 0 to year 2025, well, then I would have A of t equals 4 doubled every 10 years, but starting in the year 2025, still every 10 years. So that would be A of 2025. That's the year I started my 4 dots. It was it's 2025 now. I remember when it was 1965, 1955, a little bit, just a tiny bit. Yeah. Back was, I think, in about 1958. I think my father took me into a bank and got me a savings book account. We'll be talking about that in a minute too. So 2025 would be I'm just doing the amounts now, right? So in 2025, I think I got 4 dots, and I think in 2035, I've got 8, and in A of 2015, I had 2 dots. And we could think of that as money. Like in 1958, father took me in and I think I had $4 and I got a savings bank account. And I think it was doubling I don't remember how often. Now, I forget what the interest rate was back then. Yeah, but I think we're starting to apply exponential functions to actually the money and banking system right now. Interesting. Wonder how that works. I don't know. Maybe we should try to find out. So we got this doubling and, I actually, after 2 years, my money quadrupled. I went from an initial amount of 4, when I started out, I had 4 dots, then it became 8, then it became 16. I wonder when it triples. I wonder when my money triples. Well, you can tell this is the first time I've talked about this because I don't know where I'm going. But I'm still going to go there. I'm not even sure I got the language to describe what I want to describe. But we're heading towards Rene the cart, and that's a good thing. Rene's parked over in the corner there. But I'm not on a roll now. The cart rolls. I'm not rolling, but certainly rambling. Oh, this has been a test question. How do you turn 8 to the x into, it's kind of like a different base. Kind of like this is a base 8 and this is a base 16, but trying to get them into the same base. And I think we figured out that that's base 2. Yeah, that's base 2. That's nice. I can convert some base into some other base because all exponential functions can be written in any base you want to write it in. Right? I'm doubling every what did I say, every year over there? And that's quadrupling every 2 years. And I think we could keep this conversation going. But we've looked at the mechanics of that. We figured out that 8 could be expressed as base 2, 2 to the 3, 16, base 2, 2 to the 4. Then I can play with the exponents and I can see that there's an equivalency here. When I solve for x, I got 8. And I can see 8 to the 8 is 16 to the 6. Yes, if I put an 8 in here and an 8 in there, I get 8 to the 8, 16 to the 6. And I can't initially see that those are the same unless I change it to base 2. And then I'm looking at, 3 times 8 is 24 and 4 times 6 is 24. So something's going on here. But what if I wanted to change a base? Oh, this was another test question. What if I wanted to change b squared, which is a base, right? It's the base of a log, into b to the 7th. Well, I got to turn this exponent. I got to do something exponentially to turn that into that. And it sure looks like it would be b squared to the, I don't want a 2, I want a 7. I don't want square root, I don't want squaring, I want 7th powering. And I guess I find my answer. Kind of hard to see it, but there it is. Which brings us to 2 to the x equals 3. And I think I'm asking the question, what do I do to the base 2 to turn it into a base 3? On some level, it seems like that language fits. But I've only said it once, and I've been looking at these things for 45 years, and now I'm just saying it. God, it takes time to spot things. But I think something's going on there. So it would be nice if I had some connection here, like over here, or over there. 8 into base 16, base 8 into base 16. Sure would be nice if I could figure out what exponent turns base 2 into base 3. Well, thank you, Mr. Euler, because I think you gave us that exponent, and I think it's base E. Because I think I can write 2 to the x equals 3 in base E notation. I think 2 is e to the 0.7, and 3 is e to the 1.1. Well, it sure seems like 0.7x equals 1.1, and x is equal to 1.1 over 0.7, which I believe is the ln of 3 divided by the ln of 2, approximately, right? These are approximations. And I do believe in the textbook that's called the change of base formula, which means that whatever function I want, whether it's 2 to the x, which could have been written as e to the 0.7x, or if it's 3 to the x, that exponential function could be written as e to the 1.1x, approximately. I should use approximation symbols. And I think 1/2 to the x probably could be written as e to the negative 1.1x. And if I wanted to do this doubling every 10 years, then I think I'm looking at 2 to the x over 10 is equal to e to the 0.07x. Which reminds me of going to the bank with my father, because they had an interest rate. It wasn't 7, a rate of interest rate of 0.07. It might have, I don't think interest rates were that high back then, but it might have been 0.04 or something like that. I don't know. But, we have this thing called A equals PE to the RT, where P, this is called compound interest. And we're just starting a conversation here. So I went to the bank. Let's say I put my $4 in the bank, and it was getting 3% interest. How long would it take to double it? Let's find out. I think we're getting the mechanics to be able to solve this problem now. I think we divide by 4. I think we know how to solve an e to the problem. It's the ln of. And I think we know how to take multiplication by 0.03 and divide by 0.03. And that's going to tell me how long it takes my $4 that my father took me into the bank to deposit into a savings bank, in a savings account at 3% interest, because I know the ln of 2. It's about 0.7. It's about. And I know how to get rid of decimal places. This is, I'll multiply both by 100. Because that moves this decimal place into the 3 location, and it moves this decimal place 2 units to the right, 70. And so I now know that it's going to take me 23 1/3 years for that $4 to double. Yeah, it's a long time to wait for $4 to become $8. But, the thing about compound interest, exponential functions, is eventually they take off. So why do you study math? Because I want you to put $10 a month into a savings account and watch what happens in 40 years. I'm not sure of those numbers, but I know there are some numbers out there that are impressive. So you go find out by studying more about these exponential functions, and then you'll know. But you got to start somewhere. And so we started somewhere, and we're building into somewhere else. I wonder how long it would take to triple my money at 3%. Oh, I got a feeling it's as simple as knowing the ln of 3, which is 1.1, not 0.7. 1.1 divided by 0.03. If I multiply that by 100, I'm looking at 110 divided by 3, and that goes in, what? 3 goes into 11 with a 3, 20, 3 goes into 20 with a 6. It looks like it's 36 2/3 years to triple my money. Yeah, we're just starting to play around with some numbers. And we got to start the conversation somewhere, so we just started it. All right, so that was a bit of a ramble, but there was some purpose to it. And let's see if we can build on that purpose and make it sound a little more simple to understand. But that could take some time. Got to start somewhere. Stay safe and warm.